Good day and welcome to our class on real analysis. In today's class, we'll be talking about bounded sequence and look at examples on it. When we say a bounded sequence, a sequence A sub n is bounded if and only if the set of values that the sequence takes on, is bounded. If and only if the set of values that the sequence takes on is bounded. How then can we give a formal definition for bounded sequence? How can we give a formal definition for bounded sequence? Let's define it this way. Definition. A sequence A sub n is said to be bounded if and only if there exist two constants n and u, where n belongs to R and u also belongs to R, such that L is less than or equal to A sub n less than or equal to u for all n contained in the set of natural numbers. Our L is called the lower bound of sequence A sub n, and u is called what? The upper bound of sequence A sub n. That implies that what? For a sequence to be bounded, it must have both the lower bound and the upper bound. That means for a sequence to be bounded, it must be bounded above, that is having an upper bound, and also what? Below, having also a lower bound. It must be bounded above, which implies that it has an upper bound and also bounded below. However, if a sequence has only an upper bound or only a lower bound, then such sequence cannot be said to be bounded. It cannot be said to be bounded. For example, let's consider the sequence of the reciprocal of numbers as n moves from 1 to infinity. We want to see whether this sequence is bounded or not. Is this sequence bounded? That's the question. Before we can determine whether the sequence is bounded, let's go ahead to bring out what? The terms of the sequence. What are the terms of the sequence? Our first term will be 1. The next one, 1 over 2, 1 over 3, 1 over 4, 1 over 5, 1 over 6, and like that. What can we notice in the trend of this sequence? We can notice that the greater the n, the sequence tends towards what? Tends towards 0. Therefore, because it is moving towards 0, which will be the least number in this sequence, we know that our lower bound is equal to 0. And what is the highest number in the sequence? 1. That is our upper bound. Our upper bound is 1. And so, we know that the sequence of the reciprocals of numbers is what? Is a bounded sequence. Why? Because it has both the lower bound and the upper bound. Therefore, the sequence 1 over n, as n moves from 1 to infinity, is a bounded sequence. We'll take another example. Let's look at the sequence. That will be the second one. Consider the sequence of numbers such that n belongs to the set of natural numbers as n moves from 1 to infinity. What can we say about that sequence? The terms of the sequence are as follows: 1, 2, 3, 4, 5, 6, and it continues like that. It is also an infinite sequence. The lowest number in the sequence is 1. But do we have an highest number? No. Why? Because the bigger our n, the more the sequence tends towards what? Plus infinity. It tends towards plus infinity. So we have a lower bound, which is equal to 1, but our upper bound is tending towards infinity. So we don't have a upper bound. Therefore, this sequence of numbers is not bounded. It's not bounded. Remember we said that what? A sequence is bounded if it has both the lower bound and also what? The upper bound. We take another example. Consider the sequence n into 1 minus n as n moves from 1 to infinity. Show that it is bounded. You will recall the definition of bounded sequence. It says a sequence is bounded if it has a lower bound and also what? Has an upper bound. That is, n is less than or equal to a sub n, less than or equal to u, for all n contained in what? The set of natural numbers. Where our n is what? The lower bound of the sequence, and our u is what? The upper bound of the sequence. Having recalled the definition, we now come back to our sequence. The sequence of n into 1 minus n as n moves from 1 to infinity. What are the terms of this sequence? The terms of this sequence are what? The first term is 0 when n is 1. When n is 2, what happens? We have minus 2. When n is 3, we have minus 6. When n is 4, we have minus 12. When n is 5, we have minus 20. When n is 6, we have minus 30. And like that, like that, like that. Again, if we look at the trend of this sequence, we see that it is tending towards what? Negative infinity. Because the bigger our n, the bigger the value that we are going to get. Therefore, since all the other terms are lower than 0, our 0 becomes what? Becomes the upper bound. The upper bound of the sequence is 0. But do we have a lower bound? No. Because what? It is tending towards negative infinity. Therefore, the sequence n into 1 minus n is not bounded. It is not a bounded sequence. We'll look at one more example, and that will be on what? On a constant sequence. A constant sequence. What can we say about a constant sequence? Is it bounded or not bounded? Consider the constant sequence 2, 2, 2 down to 2. We want to show that it is bounded. We want to show that it is bounded. Again, we will try to recall the definition of a bounded sequence. A sequence is bounded if it has what? If it has the lower bound and the upper bound. L less than or equal to a sub n less than or equal to u for all what? N contained in the set of natural numbers. Now looking at this set, or the sequence of constants 2, we have 2 all through, and it is also a finite what? It is a finite sequence. So what's our upper bound here? Our upper bound is 2, because every term of the sequence is less than or equal to 2. And our lower bound is also what? 2. Since 2 is less than or equal to every term of the sequence. Therefore, the constant sequence 2 is a bounded sequence. Thank you for watching up until this point. If you have gained anything from this video, give it a thumbs up, like, and share with your friends and colleagues. Thank you. God bless you. I see you in the next video.